Hello student, today we are going to discuss about the friction. আজি আমি ফ্ৰিকশনৰ বিষয়ে ঘৰ্ষণ অসমীয়াত ঘৰ্ষণ বুলি কয় ঘৰ্ষণৰ বিষয়ে অধ্যয়ন কৰিম. Before discussing the friction, what is the friction? I want to perform one experiment today. তোমালোকে দেখিছা মই এনেকুৱা এটা অবজেক্ট এটা লৈছো when I push the object, have you seen it? When I push the object in forward direction, চোৱা মই অবজেক্টটো কি কৰিছো পুশ কৰিছো এনেকৈ মই অবজেক্টটো ঠেলি দিছো কিছু দূৰ গৈ অবজেক্টটো ৰখি গৈছে. When I push the object in forward direction, the object come to rest after traveling through certain distance. Now question is, why the object come to rest? Object to কিয় ৰখি গল যে তোমালোকে কবা যে when the object moves in forward direction, the force of friction opposes the motion of the object. The force of friction opposes the motion of the object. Force of friction এ motion of the object to oppose কৰিব. Therefore it comes to rest. হয়নি? Yes or no? Yes or no? So that is called the frictional force. So what is frictional force? The friction is the force which opposes the relative motion between two objects in contact which act tangentially along the surface of contact. Friction is the force which opposes the relative motion between two objects in contact which act tangentially along the surface of contact. তাৰ মানে কি এইখন সারফেস আছিল টেবুল টপ ইয়াৰ ওপৰত মই অবজেক্টটো ৰাখিছিলো যেতিয়া মই ইয়াৰ ওপৰত ফোর্স এপ্লাই কৰিছো when I apply a force on the body মই applied force to P বুলি কৈছো এটো force applied তে কি হৈছে this body move over the surface of the table over the top surface of the table. As a result, a opposing force act on it, and this force is called frictional force. এই ফোর্সটুকে frictional force বুলি কয়. The friction is the force which opposes the relative motion. তার মানে when this object move over the surface of the table, over the top surface of the table, when this object moves over the top surface of the table, a tangential force act between the two bodies. And this tangential force opposes the motion of the object. Friction is the force which opposes the relative motion between two bodies in contact which act tangentially along the surface of contact. এই ফোর্সটুকে ফ্রিকশনাল ফোর্স বুলি কয়. Now we want to perform another experiment. Say, এটা সোয়া এই বডিটো সোয়া এটো দেখিছানে এইখন এখন সারফেস এইখন এখন সারফেস আৰু এইখন এখন সারফেস কোনটোৰ সারফেস এরিয়া বেশি? This surface has maximum area and this surface has minimum area. Now, I want to apply a force on the body. I want to apply a minimum force on the body. I want to apply a minimum force on the body when the body is in this position. Again, I apply a minimum force on the body when the body is in this position, and I want to apply minimum force when the body is in this position. So if I apply minimum force to produce motion on the body at this position, at this position, and at this position, it is found experimentally that in all the three cases, same minimum forces are needed. বস্তুটো বুজি পাইছানে? এইখন এখন সারফেস টেবুলত আছে, এবাৰ বডিটো মই এনেকে প্লেস কৰিছোঁ, এবাৰ বডিটো মই কেনেকে প্লেস কৰিছোঁ, এবাৰ বডিটো মই এনেকে প্লেস কৰিছোঁ, আৰু এবাৰ বডিটো এনেকে প্লেস কৰিছোঁ, এবাৰ বডিটো এনেকে প্লেস কৰিছোঁ, এই পজিশনটো এনেকে আছে তাৰমানে, আৰু এবাৰ বডিটো মই কেনেকে প্লেস কৰিম, এনেকে প্লেস কৰিম, তাৰমানে লাইক দিছ, এবাৰ এনেকে, এবাৰ এনেকে, এবাৰ এনেকে. It is found experimentally that in all the three cases, exactly same amount of force is needed to produce motion in the body. তাৰমানে এনেকে থাকোঁতে যিমান ফোর্স লাগিব, এনেকে থাকোঁতেও একে ফোর্স লাগিব, এনেকে থাকোঁতেও একে ফোর্স লাগিব. বুজি পাইছানে? বুজি পাইছাতো? সেইকাৰণে কোৱা হয় the force of friction is independent of apparent area of contact. এতিয়া এনেকে ৰাখিলে কন্টেক্ট এৰিয়া সবতকৈ বেছি হ'ব, এনেকে ৰাখিলে সবতকৈ কম হ'ব. এটা আমি কি পালো এক্সপেৰিমেন্টৰ পৰা, whether I place the body like this or like this, in all the three cases same minimum force is needed to produce motion on the body. So it implies that the force of friction is independent of apparent area of contact. তাৰমানে apparent এৰিয়াৰ ওপৰত ডিপেণ্ড নকৰে. If we see under a high power microscope, then it is found that our tabletop, which appears to be normally a smooth surface, the surface is like this. Similarly, lower surface of the body is also like this. They are irregular in shape. When I place the body like this, if I see this particular point of contact, have you seen it? Have you seen my pen? If I see this particular area of contact under a high power microscope, then I have seen that these surfaces are like this. That means at this point, and at this point, the molecules of this body and molecules of this body are in contact with each other. As a result, তোমার কি হব, ইহঁতৰ মাজত molecular bond হব. Unless we break this molecular bond, যেতিয়ালৈকে মই এই molecular bondটো ভাঙিব নোৱাৰো, নাভাঙো, তেতিয়ালৈকে মোচনটো পসিবল নহয়. The minimum force needed to break this molecular bond, the minimum force needed to break this molecular bond is called limiting friction. সেইটোকে limiting friction বুলি কয়. ধৰি লোৱা এই molecular bondৰ ভ্যালুটো 5 নিউটন. Let us assume that the strength of all this molecular bond or molecular force between the surface of these two body are 5 Newton. তাৰমানে if I apply 5 Newton force, then only motion of this body over the surface of tabletop is possible. Therefore, limiting friction is 5 Newton. তাৰমানে if we place the body like this, if I place the body in this way or in this way, in all the three cases, apparent area are different, but point of actual contact are same. Since the point of actual contact are same, the same minimum force is needed to produce motion in the body, whether the body placed like this or like this. and this minimum force is called the limiting friction. This is the basic origin of the frictional force. Frictional force or origin bahut ase. We can explain the origin of friction in lot of different way, and this is the most modern explanation of the force of friction. So, what is limiting friction? The maximum value of static friction which comes into play when a body just begins to start sliding over the surface of another body is called limiting friction. The maximum value of static friction which comes into play when a body just going to start sliding over the surface of another body is called limiting friction. What is static friction? What is static friction? মই মানতে কলো যে maximum value of static friction. What is static friction? The force of friction which exactly counterbalance the applied force during the stationary state of a body is called the static friction. The force of friction which exactly counterbalance the applied force during the stationary state of a body is called the static friction. এটা তোমালোকে চোৱাচোন ইয়াত এই বডিটো মুভ কৰিব লাগিলে মই মিনিমাম কিমান ফোর্স দিব লাগিব 5 নিউটন দিব লাগিব কাৰণ মই ধৰি লৈছিলো এই মলিকুলাৰ বন্ড কেটাৰ টোটাল স্ট্ৰেংথটো তোমাৰ কি 5 নিউটন তাৰমানে if I apply 1 newton force on this body then what happens? This 1 newton force cannot break all the molecular bond whose total strength is 5 newton. Yes or no? Yes or no? If I apply 1 newton force on the body in this direction, this 1 newton cannot break all this molecular bond. Therefore, motion is not possible. But I am applying 1 newton force on it. Where that 1 newton goes, the 1 newton comes in this direction. 1 newton comes in this direction. So what is this force? This force opposes the applied force. Therefore, this force is called static friction. Now, if I apply 2 newton force on it, then this 2 newton cannot break all this molecular bond. Yes or no? Whose total strength is 5 newton? Therefore, where this 2 newton goes, this 2 newton is balanced by a force of static friction whose value is 2 newton. Now, if I apply a force of 4 newton on this body, then also motion of this body over the table surface is not possible. But I applied a 4 newton force. Where that 4 newton goes? Because a force of static friction comes into play which balances the applied force of 4 newton, That means ki force of static friction is a self-adjusting force. If the applied force on the body is zero, force of static friction is zero. If I applied 1 newton, force of static friction is 1 newton. This force of static friction balances the applied force, therefore motion is not possible. But actually, why the motion is not possible? Because this 1 newton force cannot break all this molecular bond. If I apply 2 newton, this 2 newton cannot break all the molecular bond whose strength is 5 newton, therefore motion is not possible. If I apply 4 newton, this 4 newton cannot break all the molecular bond whose total strength is 5 newton, therefore motion is not possible. But if I apply 5 newton force, then what happens? This 5 newton break all this molecular bond. And after that, if I give a simple jerk on the body, the motion is possible. The body starts sliding. Therefore, this maximum force of static friction is called the limiting friction. Here, static friction or definition to ki boli koy, the force of friction which exactly counterbalance the applied force during the stationary state of a body is called static friction. It comes into play when a force acts on a stationary body. It is zero. That means force of static friction is zero if no force acts on the body. Therefore, static friction is called self-adjusting force. Static friction is called self-adjusting force. বুজি পাইছা static friction to কি বুলি কয় self-adjusting force বুলি কয় তাৰমানে if I apply minimum 5 Newton then only motion is possible. Minimum 5 Newton. If we apply a force less than 5 Newton, it cannot break this molecular bond. Therefore, motion is not possible. Therefore, we are saying that the force of static friction counterbalance means opposite, counterbalance the applied force, and hence the motion is not possible. If the applied force is zero, force of static friction is also zero. Clear hoise? So, ইয়াৰ পৰা আমি কি গম পালো? So, we can draw a graph. আমি ইয়াত graph এটা draw কৰিব পাৰিম. Between the applied force and that of the frictional force. যেতিয়ালৈকে বডিটো ৰখি থাকিব এই গ্ৰাফটো এনেকুৱা হ'ব. This angle is 45 degree. এইটো 1 Newton, এইটো 1 Newton, এইটো 2, এইটো 2, এইটো 5 Newton, এইটো 5 Newton. তবে during the stationary state, itu rest position. During the stationary state, the relation between static friction and applied force is linear, making an angle of 45 degree. Therefore, static friction is called self-adjusting force. Once the motion is possible, ebar jodi motion to possible hoi jay, ebar jodi sliding to start hoy, teke tomar ki hobo? A smaller force can produce motion on the body. Why? But if the body starts sliding, body to the motion to starting kore. Body to the motion to the starting hoi jay. Body to motion to starting hoi jay. Starting hoi gole ki hobo? A point bilakor যেটো কন্টেক্ট পইণ্ট হ'ব সেই কন্টেক্ট পইণ্টত মলিকুলাৰ ষ্ট্ৰেংথটো সাফিচিয়েণ্টলি লাৰ্জ নহয়, অলপমান কমি যায় কাৰণে এবাৰ যেতিয়া মোশন প্ৰডিউস হ'ব তাৰপিছত অলপমান ফোর্স কম এপ্লাই কৰিলেও বডিটো কন্টিনিউয়াসলি মুভ কৰি থাকিব। তাৰমানে ইন অৰ্ডাৰ টু কন্টিনিউ মোশন অন দ্য বডি, আমি যদি বডিটোৰ মোশনটো কন্টিনিউ কৰি ৰাখিব বিচাৰো উইথ এ কনস্ট্যান্ট স্পীড, we have to apply a constant force on the body. We have to apply a constant force on the body. এতিয়া মোৰ আগতে 5 নিউটন আছিল, ইবাৰ ধৰা মই 4.8 নিউটন মান ফোর্সও যদি এপ্লাই কৰি থাকো বডিটোৰ মোশনটো কন্টিনিউ হৈ থাকিব। তেতিয়া এই 4.8 নিউটনটোক আমি কি বুলি কম? কাইনেটিক ফ্ৰিকশন বুলি কম। এখানে what is kinetic friction? The force of friction which comes into play when a body in contact with another body has actual relative motion with respect to second body is called kinetic friction or dynamic friction. তাৰমানে এবাৰ যদি মোশনটো প্ৰডিউস হৈ যায় তেতিয়ালে কি হ'ব? দুইখন সারফেসৰ মাজত রিলেটিভ মোশন হ'ব, সেখানে পয়েন্ট অফ অ্যাকচুয়াল কন্টেক্ট বিলাকৰ মলিকুলার স্ট্রেংথটো আগৰ দৰে সাফিসিয়েন্টলি লার্জ নহয়। যেটো আগৰ দৰে সাফিসিয়েন্টলি লার্জ নহয়, অলপ কম ফোর্স এপ্লাই কৰিলেও বডিটোৰ মোশনটো কন্টিনিউ হ'ব। কাৰণ 5 নিউটন এপ্লাই কৰোঁতে বডিটো মুভ কৰিছিল, ইবাৰ যদি মই 4.8 নিউটনো এপ্লাই কৰোঁ বডিটো কন্টিনিউয়াসলি মুভ কৰি থাকিব। এই 4.8 নিউটনটোক তেতিয়া কাইনেটিক ফ্ৰিকশন বুলি ক'ব। That means kinetic friction is slightly less than the limiting friction.